All right, hey guys, we're going to do 3.8, interpret two-way frequency tables. This is the second to last new topic in the chapter. There's more statistics, so I can organize paired data. Paired data is just kind of like two things you're comparing into a two-way frequency table, just a way to organize information, and then make conjectures, kind of like predictions or like using the data to like think about it, about data from a two-way frequency table. Okay, so this is the vocab. We'll add that later. Problem number one, the owners of a ski resort want to know which is more popular, skiing or snowboarding. The result conducts a poll asking visitors their age and which activity they prefer. The results are shown in the table. So, again, two types of data. We've got age versus preference for skiing or snowboarding. So it's age, that's one type of data, and then skiing or snowboarding, say, that's kind of like what you pick in the survey. Now, the total number of people surveyed is right here. Okay, and we have the total for the number of people that were 35 and under that were surveyed, and then over 35 here, and then who likes snowboarding versus who likes skiing versus who likes snowboarding. What information can the owners of the ski resort determine from the data in the table? Well, they can see that the majority of people who come to their ski resort are over 35, and the majority of people prefer snowboarding. So that's kind of like how we use this table or these types of tables, right? So you'd say the majority of people surveyed are over 35 and prefer snowboarding. We can actually get way more granular or more specific with the data if we say well, for skiing over snowboarding, right, the over 35 people vastly prefer skiing to snowboarding, but then when you look about it, the 35 and under, right, you've got more of them prefer snowboarding to skiing, right? So why would this be useful to the owners of the resort? Well, you could think about something like, well, do they want to cater to younger people or older people, right? So if they want to cater to older people, right, then they're probably going to focus on skiing, right? But if they want to focus on younger people, they'll definitely focus on snowboarding because it's 31 to 12, right? So why would this be useful to the owners of the resort? They can use this information to make business decisions. Right? That's why you have data like this, right? Is so that it can help inform your decisions, right? Otherwise, there's no point to it, okay? Victoria asked 100 people at the school whether they prefer digital or print textbooks, constructs a two-way frequency table that shows the relationship between the people's position and their textbook preferences, right? So we've got the data right here, and then it's been transferred to the table. We're just going to complete the table, right? So when you don't have your totals, all you do is kind of add across and add down, right? So 42 plus 28 is going to be 70. Okay, and then 6 plus 24 is 30. Okay, and you'll notice that that adds up to 100, which is the amount of people surveyed. And then you'll notice that 42 plus 6 is 48, and then 28 plus 24 is 52. And if you add those two together, you also get that 100 people right there, okay? I should have a question on here, my bad. So that's just putting your table together, right? You'd say students prefer digital, teachers prefer print, right? That would be kind of a way to summarize this. Which is not surprising, right? Prefer digital textbooks, and teachers prefer print. But, right, you've got 70 students versus 30 teachers that were surveyed, right? Which, I mean, yeah, you're going to have more students than teachers. But anyway, that's kind of like how you would interpret these, construct and then interpret, right? So we get here, interpret two-way frequency table. So we've already got one done, right? The two-way frequency table shows the results of a media survey. People responded to the question, do you spend more time watching the Winter Olympics, the Winter or the Summer Olympics on television? And then decide if the following statement is true or false and explain. Okay, so this right here, more men than women prefer the Winter Olympics, right? So we look at this right here, we've got men versus women, that's one of your sets of data, and then winter versus summer, that's the other set, right? So if we take a look at, there's 150 people surveyed, right? Of those 150, 79 were men, 79 for women, okay? And if we kind of like take a look here we would say that 45 men to 27 women prefer the Winter Olympics. We'd say, so more men than women. Should say more men than women prefer the Winter Olympics, right? And you can actually get a little bit more in depth with this if you wanted to like take a look at total number of men versus total number of women, right? So you had a 45 out of 74 for men, and then 27 out of 71 for women, right? So then you would kind of like convert this to be the same. We'll actually just do a percentage, and this kind of like actually goes into the next topic. But we'd say 45 divided by 74 gets us to 61%, and then 27 divided by 71 gets us to 38%, right? Okay, so we could definitely see that even the percentage of men is higher, right? So yes, this is true. This is true because 61% of men versus 38% of women prefer the Winter Olympics. I mean, yeah, I don't know if this is true or not, but according to this data, it is, right? All right, construct and interpret. 200 people responded to a survey. Of those who had green eyes, 7 had blonde hair, 9 had brown hair, and 2 had red hair. Of those who had brown eyes, 76 had blonde hair, blah, 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 blah. Constructed to a table to display these data. Okay, I don't know, that sounds weird, but data is plural. Right? Then identify the least common combination of eye and hair colors, okay? So 200 people. That's how many people were surveyed, so that's always going to go in that kind of like lower right corner of these tables. Of those who had green eyes, so we'll say green eyes, right? Okay, 7 had blonde hair, 9 had brown hair, and 2 had red hair. Oops, my bad, 2 had red hair, right? We don't want to put that in the total. Of those who had brown eyes, 76 had blonde hair, 89 had brown hair, and 17 had red hair. Construct it to a frequency table, then talk about the least common combination. Okay, so we've got the total, we've got all this. Now how you do this is you just kind of like add down and then add across. So 7 plus 76 is 83, 9 plus 89 is 98, 2 plus 17 is 19. Now we can double check our work here, and as long as these three numbers add up to 200, then we're good to go. So 83 plus 98 plus 19, and we get 200. So our calculations are correct that way. Now 7 plus 9 is 16, plus 2 is 18. Okay, and then 76 plus 89 plus 17. I'm just going to use the calculator here. 76 plus 89 plus 17 gets us to 182, right? And 182 plus 18 is 200, okay? So then we're looking for the least common combination of eye and hair color. So again, eye and hair color, we're doing eye color as one set of data, and then hair color is the other set of data, and these are the two things we're comparing, okay? So the least common combination, we look basically for the lowest number, which is right here, right? That 2 out of 200, so basically 1%, right? So the least common combo, the least common combination is green eyes and red hair. And then explain because it's because only 2 people out of 200 had this combo. Okay. All right, last one. What kind of association does each scatter plot represent? If we take a look at A, we've got positive. We'd probably also put that strong. Okay. B would be negative. It's going down, right? We'd also put that as strong because it's clustered pretty well. And then C is no association. Probably should have had one that was like a weak association as well, just so we would have a little bit more variety. But yeah, positive, and like it's a increasing trend. We have a decreasing trend for B, and then it's very hard to draw a line through the data for C. So there we go. Lovely. Thank you.